Hello, and thank you for having me come and chat to you today. My name is Hugh Ong. I'm one of the innovation managers here at the Food Agility CRC. It's an absolute shame that I can't be there in person given current policies around risk appetite and travel and so on, but I'm hoping this will be fun nonetheless for yourselves. I've been asked to speak a little bit about the innovative digital trends that we're seeing in our portfolio, as well as the applications of emerging technologies that we're seeing in research projects. Throughout this presentation, I'll spend a little bit of time providing an overview of certain technologies and walk through a few examples of their use in some of the projects in our portfolio here at Food Agility. Hopefully, it will spark some inspiration for yourselves around using innovative technologies to solve for your challenges or unlock opportunities for your own precision agriculture journeys. So who are we? We're the Food Agility Cooperative Research Centre, and our goal is to be able to use the power of data and digital and research to create a sustainable food future for producers, consumers, and communities. So CRCs essentially exist to bridge a gap between research and industry. According to the surveys and statistics from the OECD, Australia has consistently performed poorly when it comes to the transfer of research into industry. And this has been a consistent trend for several decades, which is a strange gap because when we think about Australia's higher education research institutes, they rank generally very highly. This includes things like education and research quality, so publications, IP generation, and inventions. On the other hand, though, the collaboration between business and industry with research ranks quite low. So this includes things like partnerships or that transfer of technologies from laboratories and into the hands of end users and customers. And that sort of innovation and business outcomes in the format of ROI, for example. So really, that's why the CRC exists, to provide a pathway for commercial impact. We're kind of a response to several barriers that industry and businesses face when engaging with researchers. That could include things like the language that researchers use that might be different to what's used in business, the culture, and of course the methods as well. So our role is to basically inject innovation and agile practices as a stepping stone to apply research and methodically build and test prototypes and MVPs together with businesses so that the end result is a fit for purpose solution which can be adopted at scale. There are several CRCs out there. Some of them are focused on finance and manufacturing and even space. And we are one of several different food CRCs. The food space for us is actually quite broad. So we look at problem spaces that relate to production or logistics and supply as well as consumer. So, but having said that though, the things that is a little bit more narrow for us is the solution space. We care primarily around digital and data-driven solutions, and that's really our skill set. So I promise this will be the last slide where I spoke things about the CRC, but essentially being a cooperative research center, collaboration is incredibly important to us. Some of the companies that you see on this list are either actively working with us on projects today or have been working on projects with us in the past. So please join us and become one of our Facebook friends. At the CRC, we're seeing a number of new emerging technologies applied in our research projects. And for the remainder of this presentation, I'm going to spend some time providing a high-level overview of these technologies and walk through an example or two for each of our projects. So this includes things that I'm listing here: data analytics, sensors and IoT, and no presentation on innovation is complete without talking about blockchain, of course. So I'll dive a little bit into that in a moment too. The concept of data analytics is nothing new. It's just the idea of taking information and making decisions from it. We do that on a daily basis. But the term big data refers to when the scale and complexity of data analytics is no longer trivial and starts requiring things like very specific skills or infrastructure that most people just simply don't have access to. A really good way to think about big data analytics is this little 4Vs framework that I've got over here. Volume, we kind of talked a little bit about. This is just the sheer scale of how much data that we are generating. Velocity talks to the speed of the data sets. So things like a sensor out in the field might ping and generate one data point per minute, but others might generate thousands, if not hundreds of thousands of data points per minute. How do you then account for that change in your data sets as you do your analytics as well? Veracity talks to things like the biases that you might introduce or some of the accuracy of some of the data sets. And how do you then, when you do your analytics, make sure that you account for some of those issues? And variety talks to then all the various different sources of information and data that you have to then account for and somehow integrate into your analytics as well. And then what do you do with this data? Well, Gartner has a really good frame that describes the kinds of things that you can create from a data set. The most basic is descriptive analytics, which is just, here's a data set and we think that the data says X, Y, Z. And you can sort of understand then what your data is trying to tell you. The next step is, if your data is looking like this, then if we extrapolate that out a bit, how do we then predict what's going to happen next? And that's predictive analytics, and that's a little bit of additional complexity. And then the last sort of great thing that we want to be able to do with data is to create prescriptive analytics. So this is the idea that if the data is showing us that the trend is going this way, then what's the advice? What's the thing that we should do, and what's the decision we should make? And being able to be analytically driven when it comes to decision making. And of course, the last one I've added myself is automation. So if you can take away some of that analytics and give it to a machine to do, why not also then give some of those mundane decisions to a machine to do as well, so that I don't have to do that? That would be fantastic. This first project that we'll look at is all about being able to better smooth out supply and demand. So as you're all very, very familiar with, I'm sure, planning to supply fresh produce with market demand and consumer expectations is highly complex, with many, many variables, like weather, for example, having big impacts on things like supply shortage or supply excess, for example. So this project is all about being able to create predictive models that are surfaced on a visual interface, so that an organization like Mulgawi and its users within the company will be able to make better production and sales decisions. The idea is that this will help facilitate discussions with their customers, as well as their grower communities that they interact with. Avocados are fascinating to me. I love avocados, but when I buy them, they sit on my shelf forever because they're just rock hard and taste like rubber for the longest time, and then they're perfectly ripe for about 13 minutes before immediately turning into this disgusting black mush. Which is why, as a millennial, I'm quite happy to spend $20 getting a nice smashed avocado toast at my local cafe instead of paying for my mortgage, because I know that they'll get it right. But can you imagine this, though, at the scale of export markets? It's hard to guarantee the ripeness of avocados when it hits the importer's shores, which also becomes a big source of small but quite frequent claims and returns for growers. This project is a collaboration between Costa as well as the Queensland University of Technology and the Queensland Government DPI. And this whole project aims to develop essentially a data model that identifies lead indicators, such as growing conditions or harvest timings, storage duration and temperature, and handling and shipping practices, all trying to be able to optimize the shipping of avocados to reach those shores at the most ripe or the most desired ripeness. The result will be a user-friendly decision tool for essentially Costa Avocado and its internal team members to be able to road test along the supply chain. The next technology I'd like to talk about is something that I'm sure the precision agriculture community is very close to. And the idea of using sensors instead of human inspection is not new, and obviously has many advantages like scale and speed and accuracy and objectivity. But it's only really been in the last few years that the concept of IoT and distributed sensors has really taken off, and I understand this to be essentially the result of two kind of things increasing and decreasing. So connectivity and availability and battery capacity increasing to the point where these technologies started to become more practical, as well as a decreased size and cost. So not only are these things more practical, they're also a lot more sustainable when it comes to creating a business model from them. So we're starting to see sensors obviously becoming applied to many non-traditional scenarios, such as building management or healthcare and even smart homes. And we're certainly seeing a lot more application of sensors and IoT in agriculture as well. This project is all about oysters, and oysters are super interesting. They're a great example of the saying, you are what you eat. They're filter feeders, and they get a lot of delicious flavor from the plankton and microfauna that they consume throughout the day. But during heavy rainfalls, the resulting runoff can really trigger the growth of things like harmful algae and bacteria and pathogens that when they filter that through, we probably don't want to eat that stuff because it makes us very, very sick. So what happens at the moment is that after heavy rainfall, water is taken to labs and results can take up to something like 7 days to come back. And during this entire time, none of these oysters can be harvested. So this leads to things like losses of up to $100,000 per day of lost revenues for farmers because they're unable to harvest some of these oysters, despite the fact that potentially some of this rain might have happened somewhere else in a different estuary, but having been forced to have these closures regardless because of quite heavy regulation, which to me is a good idea because I don't want to get sick from my oysters anyway. But it turns out that salinity is actually a great indicator of oyster edibility. So this project is a collaboration between the Yield, the University of Technology in Sydney, and the New South Wales DPI as well, Department of Primary Industries. In this case, the idea is to apply real-time water quality sensors to be able to provide an alternative way to demonstrate that the water is actually safe and the oysters that are in the waters can actually be harvested and consumed safely. This next project is all about summer fruit, and subjectivity. Essentially, for example, I really like black plums. I like how sweet they are. I like that sort of deep, rich sort of flavor that they have and that mushy texture. But all of those things that I just talked about are highly subjective. My version of sweet might be very different of your version of sweet. The summer fruit industry sends a lot of stone fruits to especially Asian markets, and because of these subjective quality indicators, it's really often quite difficult to be able to meet customer preferences for things like size and taste and color and texture in a repeatable way. This project is a collaboration between several different organizations. We have technology companies who are the Green Atlas and the Reuben Technology that I've got listed here. We've got RMIT, we have Summer Fruit in the Summer Fruit Industry Body itself, as well as Agriculture Victoria. This project includes a suite of technologies that are being tested. These include things like spectrometers, LiDAR, machine vision, as well as a few others to be able to accurately create measurements around sweetness and firmness, maturity to be able to detect internal disorders, detect size, and also help to predict yield. And a lot of this is all geared towards helping growers minimize things like export disputes. But on the other hand, it also helps farmers and growers to be able to better triage their fruit as well. So perhaps if someone is having a particularly great year and the quality of the fruit is really good, then rather than sending their fruit to a jammery, they might want to then unlock some of the revenue that's slightly higher when it goes through a certain export market, for example. And so the next thing I want to talk about is blockchain. But before I jump straight into blockchain, let's talk about ledgers. So traditionally, a ledger is a book that contains a transaction history. So details like me sending money to you and how much and when was this done and so on and so forth. These days, though, these aren't books anymore. They're held digitally by institutions like banks, and the banks spend a lot of time and money and resources in making sure that these things are kept safe, because not only are they really massive stores of information now, but they're also intensely private. So when it comes to bank digital ledgers today, they might be kept at things like data centers and data warehouses, which might have things like backup power generators for when the grid falls off and they might have to use a diesel generator to keep things going. They'll have incredibly expensive and hefty cybersecurity protocols and technologies and systems to make sure that this information is kept incredibly safe. Conversely, something like a distributed ledger, so like a blockchain, in this sort of format, every single participant on a distributed ledger has a copy of that ledger. So this means that when new transactions are recorded, each of these ledgers are also updated. And the way that this is kept safe is through the process of encryption. So I have my own encryption key, you have your own encryption key, and without your key, I can't see what's happening on your transaction there. So the entire ledger is encrypted, but I can see what's happening with my transactions, or I can see what's happening with transactions for keys that are given to me as well. And that really helps to reduce down the amount of infrastructure that's needed to keep a distributed ledger going versus a centralized ledger like the ones I described for banking. The advantages of a distributed ledger therefore means that there's no single point of failure. If my network node and ledger fails, but there's at least several other up to millions of different sort of network nodes that are still retaining this ledger and keeping it going. It's very, very minimal infrastructure. It requires only really my computer or my hardware to be on and recording new changes to the ledger. I don't need an entire data center to have this going. It's also immutable, which means that I can't go into there and corrupt some of that historic data like you could with a centralized database, because I've got a copy and you've got a copy and everybody else has a copy, and therefore we'll be able to detect any of those changes that shouldn't be there. The last one's a bit of an interesting concept, is this idea of smart contracts. So where a traditional ledger, you can only really record transactions and send money. In a smart contract scenario, in a blockchain, you're able to actually transact and send information and instructions. So smart contracts are this idea that you're able to then create these if-then statements and start creating things like automation. You would use a blockchain over a traditional centralized ledger when there might be something like many untrusted participants, where you might also have some manual workflows that you could digitize and automate through the use of smart contracts. And often when there is no logical central facilitating body, so where transactions with money, it might make sense to have a bank there. Some of the other ways that you might interact with others may not necessarily make sense to have a facilitating body that currently exists today, and you may not necessarily want to create one. A good example of a blockchain project is our seafood tracking and traceability project with the Sydney fish markets. The idea here is that the auction process at the fish markets is somewhat traditional, with participants needing to physically inspect fish on the auction floor. This is a somewhat subjective process to identify quality and doesn't really guarantee much in the way of provenance either. So in a project in a collaboration with the Sydney Fish Markets and the University of Tech in Sydney, as well as Ultimo Digital Technologies, this is a project that uses a variety of different sensors that report on things like location and temperature, and even an e-nose that measures the actual freshness of these fish, and records this information digitally, encoding it onto a blockchain ledger. This information is then exposed in some form of a consumer application, and is also a key enabler to be able to create some kind of an online auction platform that's in the works. Technology isn't a solution in and of itself, which is why when we do research projects, we want to make sure that we have that really strong industry and business collaboration to ensure that these solutions have the right puzzle pieces for solving problems at the right scale and in commercially viable ways. Some of these puzzle pieces include having people, so the right people with the right skills and training and capacity to run these things ongoing. Having really strong processes around operating procedures and systems management. Having the right policies in place to make sure that the governance of these solutions is good and there's ongoing compliance to reduce risk and make sure that everything is legally good. And of course, when it comes to the technologies itself, making sure that these technologies find a forever home that helps them achieve scale and performance and resilience, and of course, security that we critically need as well. So what's over the horizon? What's coming up next? For us, we're definitely seeing a lot of interesting themes coming into the current front part of our pipelines. We're seeing a lot more projects and proposals which are all about using machine learning and artificial intelligence to do things better and start creating more automation. We're seeing a lot of proposals coming through that are all about sustainability and natural capital. Lots of discussions now, especially around carbon and what carbon means to agriculture and agricultural management. But then beyond this, so what else is happening? There's quantum computers, which are rapidly becoming real. We have a lot of robotics discussions at the moment as well. So really the future is super, super exciting. So that brings me to the conclusion of my presentation. So thank you very, very much for taking the time to listen to my talk. I'd love to sort of hear a little bit more about yourselves as well. So if you have any questions you might have around content, or you'd like to learn a bit more about the CRC itself, or just generally want to be able to talk shop, just let me know. This is my contact details at hugh.ong@foodagility.com, and I'm really looking forward to hearing from you. I hope you enjoy the rest of this SPAA event, and I'm hoping that you have an enjoyable rest of the day as well. Cheers. Thank you.